All right, we're going to do number 12 on the back of the review sheet. It says a wooden block weighing 130 newtons, so given the weight is equal to 130 newtons, rests on an inclined plane. The coefficient of sliding friction between the block and the plane, mu, is equal to 0.620. Find the angle, so I want to find theta, at which the block will slide, so that means it's moving, so that's kinetic, down the plane at a constant speed. And the reason I'm going to write constant speed is constant speed means that the acceleration is 0. Alright, so first I'm going to draw my free body diagram. Now this is on an inclined plane. Now before I do anything else, I have to establish my sign convention. The block is moving down the plane, and this is going to be important because I always want to have my sign convention going in the direction in which I'm applying Newton's second law. So down the plane is going to be positive, which is my x, and then going this way is going to be y. So now I'm going to draw all the forces. So if the block is moving down the incline, I know that the frictional force always acts opposite the direction of motion, and it always acts parallel to the surfaces in contact. The force of weight always acts straight down, and then the normal force always acts perpendicular to the surfaces in contact. So again, this is my free body diagram. Here are my surfaces in contact. There's no one is pulling or pushing that block down the incline. The block is moving down the incline because when the angle is great enough, it's going to move by itself. Okay? And what we're going to do is we're going to solve for this angle here, theta. The next step is I need to have all my forces going perpendicular and parallel. So the weight is not perpendicular and parallel. Now, I'll just draw it on here. Instead of the weight, I'm going to replace it. And these components, they act head to tail like that. And here's my 90-degree angle. Now, just so I can see it a little bit better, I'll draw it to the side. Here's F of G, my weight, acting down. And I'm going to draw the components. Remember, these have to form a 90-degree angle. This angle here is similar to this angle here. And this is going to be FGY, and this is going to be FGX. Now, when I look at my triangle, even though I don't know the angle, I can still do what I normally do. So FGX is equal to FG sine of theta. Why is it sine? Because FGX is opposite the given angle. And then FGY is equal to FG cosine of theta. How do I know this is cosine? Because it's adjacent to the given angle. Now I'm going to redraw my free body diagram. So now, when I redraw it, again, I want to have my sign convention, just so I can refer to it. This is positive. And FF stays the same. Fn stays the same. And instead of Fg, I'm going to replace it with Fgy and Fgx. And these directions are extremely important. So again, I look at this from where I start to where I end up. These have to be head to tail. So these directions are important. Now I know that I don't have theta. But I know on these types of problems, usually I'm going to do three things. The three things I'm going to do is I'm going to sum forces horizontally, I'm going to sum forces vertically, and I'm going to use the mu equation. Do I necessarily have to do it in that order? No. But I know those are things I'm going to do. So you don't just give up and say, oh, I don't know theta, I don't know what to do. You go through all the steps that you normally go through. So let's sum forces horizontally first. So summation of f of x is equal to ma. Is this block accelerating down the incline? No. It's moving at a constant speed, so this is 0. Now I'm going to replace this with all my forces going in this direction. So I look at my free body diagram. So FGX is positive. F of F goes in the opposite direction, so that's negative, and that's equal to 0. So FGX is equal to F of F, which is equal to FG sine of theta. Now I sum forces vertically, and I say summation of F of y is equal to ma. Is this block accelerating up? No, it's not moving that way, so that's 0. I now replace this by looking at my free body diagram. So Fn is up is positive, minus Fgy, and that's equal to 0. So F of n is equal to Fgy, which is equal to Fg cosine theta. The last thing I can do is I can use my mu equation. So mu is equal to F of F over F of n. So F of F is Fg sine of theta over F of n, which is Fg cosine of theta. And now I see the Fg's cancel out, so I didn't even need to know that. Sine over cosine is tangent. Mu is 0.620 is equal to tan of theta. So now on my calculator, I press 0.62 second tan, and it comes out to be 31.79. So theta is equal to 31.8 degrees. Now this is what we did in our lab the other day. Remember in the lab when we put it on an incline and we had 4 different surfaces, and we tried to find the angle at which the block would start to slide at a constant speed? Do you remember that? And we just used tan of theta, but it was different because the coefficient of friction for pine on the different surfaces, we had cork, we had cardboard, we had rubber, and we had sandpaper. Those were all different, so the angle was different. Now some people maybe on the homework just memorized, oh, tan of theta is the angle at which it slides. Now, a lot of teachers teach that way, and people just memorize it, but you can easily find that mu is equal to tan theta for the angle at which it just starts to slide and move at a constant speed.